Continuing with section 6.1, which is area between curves. We did a couple of examples, and this was one example I left for you guys to integrate. I set up the integral view. Remember how we do this problems. Question gave us two curves or two functions, but we don't know which one is above and which one is below, and what are the bounds, like from where to where we have to find the area. So the steps for the problem are the first thing we do is find the x coordinates of the points of intersection of the curves. Then we figure out which function is on top and which function is at bottom. We set up the integral, and then we just integrate and plug in the bounds, and we get our answer for our area. So I had set up for you guys up to here. So further, I integrated function. X became x squared over 2. In place of 6, I got 6x, and then minus x to the third over 3, and limits from negative 2 to 3. Then I plugged in the limits and then simplified, and I got my answer to be 125 over 6. So can you see there is a lot of work over here? Now if you are doing this problem, you may do up to here, and you may use a calculator if you want, but don't give the answer in decimals. Give the answer in, leave the answer in fraction, and just the improper fraction, okay? But just the fraction, not the mixed fraction. So leave it like this, 125 over 6. Let's go look at another one, which is slightly different from the ones we just did, in the sense that in these ones, well, we could have drawn the graph over here. We draw the graph. This is y is equal to x plus 6. Somewhere here, let's say we have 6. So the function goes like this. Where does this meet? That is the x coordinate. So it looks like this will be at 3, and then this is at negative 2. So you notice here, the one function is above all the time in the interval, and the other function is below all the time. The same situation we saw in the previous example. So what is the difference between that problem and this one? Well, first is that we are given the function in terms of y, not in terms of x. So x is a function of y here, and we don't have two functions of two functions of x. I mean, y equal to function of x. We are not given it that way. If we try to write this one, this will not be just square root of x. This is wrong, because y has to be plus minus square root of x. This is correct. So now we have two of these, and then we have y is equal to x minus 2. Now graphing this would help us understand what is happening, or what situation we are in. So what is x is equal to y squared? You can think of it in two ways. Remember, y is equal to x squared is a parabola with opening up, and yeah, basically you can. So x is equal to y squared will be a parabola opens right. So it's like this, passing through 0, 0 and opening out. This is the x is equal to y squared. Also, you can think of it like this, that you are getting y is equal to plus minus square root of x. square root of x looks like this, and minus square root of x looks like this. The same thing. So we have a parabola like this. And then we have the equation y is equal to x minus 2. So let's say this is negative 2. So then this will be 2. So the line goes like this. Which is meeting the, so this is square root of x, this is minus square root of x, and this is x minus 2. So notice that we have three functions now, and this is our area. So we cannot say here that we have on the top one function, at the bottom another function, because over here, if you look at this, this is all the time above, but from this point of intersection, this coordinate will be here. From x is equal to 1 to whatever x coordinate is over here. The function square root of x is above and the function x minus 2 is below. But between 0 and 1, between 0 and this point, we have, if I draw a vertical line here, we don't have the x minus 2 below, but we have negative of square root of x is below. So if you graph the function like this, it's easier to see what your integral will look like. So we have to find the points of intersection. So we cannot do the x first, we have to do the y first. So we set the x is equal to each other. So one says x is y squared, the other says x is y plus 2. You can find the x from here. And now we set the x is equal, so we get y squared is equal to y plus 2. Y squared minus y minus 2 is equal to 0, which gives y minus 2 and y plus 1 equal to 0, which gives me y is equal to 2 or equal to negative. Now using these values of y, now we can find our x. So when y to negative 1, x equal to, well, you can use any of these equations which you plug it in here. Y is negative 1, so x is y squared, so it will be negative 1 whole square, so 1. And when we plug it in the next one, negative 1, so by x is equal to negative 1 plus 2, which is 1. So both ways you get x is equal to 1. Then y is 2, x is, again from both of them you get x equal to 4. So these are the bounds on x. So when you set up your integral, you will start with 0. I can do it over here so we can have a look at the graph. So it will look like integral from 0 to 1. And remember, in this interval, the upper function is square root of x minus negative square root of x. The key function is negative square root of x. Plus integral from 1 to 4. Now the top function is square root of x. The bottom function is x minus 2. This gives me 0 to 1. Now when we simplify this, negative, negative, positive, so x square root of x plus 4x, or 2 square root of 1 to 4 square root of x, or you can put it like x to 1 half minus x plus 2. Yeah. You can also put this as 1 half. Now we integrate. So we get equal to 2x to the 3x over 3 plus forgetting the dx here. So the integral was bounds are from 0 to 1. So the bounds from 0 to 1 plus the bounds are from 1 to 4, but the function is giving me x with 3 halves over 2 halves minus 4 to 2x. Bounds are 2 to 4. So plug in the bounds. Okay, first let's simplify it a little bit. This will give me 4, 3 plus so we put 3 to the half x plus 2x and the bound in 4 over 3. Then factor out 1 minus 0 plus 2 over 3 into 4 raised to the power 3 halves minus 4 over 2 plus 2 into 4 minus having in the lower limit, which is 1, 2 over 3 into 1 raised to 3 halves, 1 raised to 3 halves, minus 1 square over 2. So we end up getting 4 over 3 in first expression. So square 4 into the 30 halves. So how would you simplify that? Then this can be written as 4 the square root of 4 whole to the third, or 4 to third whole square root. So in this case, we will have to first raise it to power, which gives us 64, and square root 4 is 8. But I think the other way, it's much easier, because we first have to do the square root of 4, which is 2, and 2 cube is 8. You don't even need the calculator for that. So we get 2 or 3 into 8 minus 16 over 2 plus 8 minus 2 over 3 into 1, which is just 2 over 3. Now I'm distributing the sign as well. So negative, negative, positive, plus 1 half minus 2. And now simplify that. So I'm going to combine the terms which are 3 in the bottom. This is over 3 plus this is 16 over 3, and I have another over here which is over 3, so minus 2 over 3 plus, so this is 8 and that is 8, so minus 8 plus 8. And then plus 1 half minus, so this cancel, gives me 18 over 3 minus 2 plus 1 half. Sorry, it was minus 2 plus 1 half. So minus 2, so 6 minus 2, 4 plus 1 half, 4. Try for you, same problem, done in a slightly different way, which is quicker and easier. But this is your choice, how you want to do it. Get the graph again. we have situation this. Okay. So if you think of it like looking like this way, in the previous example we're looking like this, which one is above and which one is below. So now, because this is given as a function of y, we have to look at horizontally. Which one is to the right, which one is to the left. So first point of intersection, which we already did for y, remember y was, the y would be -1 and -1 and 2. Y values are -1 and 2. So think about it. 1 is ahead and this is 2. From -1 to 2, now we are taking our interval on the y-axis or vertical. So we can write area is equal to -1, 2. So from -1 to 2, we have one function which is on the right all the time, through the whole interval, and another function which stays on the left. So which one is on the right? -2. Which one is y minus 2? Sorry, y plus 2. And the one on the left is y square. So this is going to be y square over plus 2y minus y cube over 3. Integral from -1 to 2. Plug in the limits. We get 4 over 2 minus 3 minus 1 over 2 minus 2 plus 1 over 2, which is equal to, so this is going to give me 6 minus 8 over 3, and this is going to give me let's just keep it like -1/2 plus 2 minus 1. Six plus 2 is 8, and I combine two terms, -8 over 3 minus over 3. We put them together. What is left is -1/2. Now we get 8 plus, or minus if you want to keep in mind. It will become 8 plus 1 over 3 minus 1/2. So 8 plus 1 is 9, 9 over 3. So 8 minus 9 over 3 minus 1/2 is equal to 9 over 3 is 3. So 8 minus 3 is 5 minus 1/2. So I get 9. The same as before. So these type of problems you have to think about how to set up the integrals. The main task is to set up the integral correctly. To figure out how many pieces of integrals we will have, or how many integrals we will have in our solution, and also what are the bounds, and which function is going to be written first and minus which function. So that's all examples I could show you. Hopefully you will have some idea how to do the problems.